Right. So these are on Maths Watch. These are some non-calculator questions. Go to the transcript. Got some calculator ones, and then we've got the two past papers. Okay. So what we can look at the non-calculator questions to start with. So if you want to get these up on Maths Watch, you can, or you can just get some paper. Right. So we'll have a little look through, and any questions which you think maybe are more difficult, we can go through. Okay. So I think the first question will probably be quite straightforward. That's just getting a protractor and drawing the angle. Question 2 is quite useful. This is just working out what terms refer to the different parts of the circle. Okay, so from the middle to the edge, that is, do you remember what that is called? So from the center of the circle to the edge of the circle. So that one is the radius. And the actual middle of the circle, so here, that is the center. And this line, which goes from one part of the circle to another part, but not through the middle, we call that a chord. Okay, so we've got those different circle terms. And do you remember what a line which touches the circle is called? So if it just touches it in one place. Do you remember what that line is called? So that is actually called the tangent. It's not actually the secant line. The secant, that's a good term actually, is like a chord, but it just carries on. So a secant line would be the same as the chord, but it would just carry on through the circle. So it's actually the tangent. Okay, the tangent touches the circle in one place, right? T for tangent, T for touch. Okay, and the last one is the diameter. So diameter goes from one part of the circle on the edge through the middle of the circle to the other edge, like that. Okay, that goes through so that basically is double the radius. Okay, that's just like a little introduction there. So we'll do a couple more. I'll send you I've got all the answers to these. I put them on the team as well, so you can have a look at those as well. So I think 3 would be fine, right? So A is quite easy. The only thing to remember with B is to make sure all of your tenths, units, hundredths line up. You've got 5.26, you've got 12.98, and you would just have to add those up. I think that's quite easy. So all of these questions now are based on the 2020 paper. So they're all based on a recent past paper, basically. So we'll have a look at number 4, okay? So number 4, this is fraction of an amount. So how do we work out the fraction of an amount? So 4/5 of 30, or 2/9 times 35, because of means times. We need to remember to divide by the something, and then we times by the something. So do you remember what we have to do here? If I want to work out the fraction of an amount, Yeah, brilliant. We divide by the bottom and then times by the top. So we divide by the bottom times by the top. So with this first one, 4/5 of 30, you'd have to do 30 divided by 5, which would be 6. And then you'd have to take your answer and times it by 4, which is the top. So 6 times 4, which would be 24. And that would be our answer there. Okay. So have a go at B. It's the same thing because times means of, or of means times. So we've got to do the same thing for B. So have a go at B. If you can get some paper, Josh, maybe. And just have a go at B, and then we'll go through in a sec. So what we'd have to do for B would be 45 divided by 9, which is going to be 5. And then we'd have to do 5 times 2, which is 10. So we'd have 10 there. C is the same sort of thing. We're basically working out 1/6 of 24. So we'd have to do 24 divided by 6. Yeah, answer's 10 for B. Well done. Yeah, exactly. And then for C, you just have to do 24 divided by 6, which is going to be 4, times by 1 is still 4. Okay, so that's fractions of amounts. So we'll move on to the next bit. I think the next bit is not too bad. So what is the output when the input is 4? So these are function machines. So normally the input will be a letter, okay, but for this one it's just a number. So when the input is 4, I'm going to put 4 where the input is, and I'm just going to follow the steps in the function machine. So they want me to subtract 7 from 4. So I need to do 4 take away 7. Now, if I think about a number line, there's 0, 4 is here. I'm actually going to get a negative number, right? Because I'm going to have 3, 2, 1, 0. We've taken away 4, but I've still got 3 to take away. -1, -2, -3. So I would get -3. Then I have to divide by 3. So I need to do -3 divided by 3. Yeah, that's exactly right. So what do you think -3 divided by 3 will be? Well, -3 divided by 3 is going to be -1. So that would be our answer there. Because when I do a minus divided by a plus, I get a minus. So my answer would be -1. Okay. Now, obviously, if you've got any questions, Josh, just ask by all means. Number 6. Oh, yep. So with number 6, we've got a number machine. We want to write down an expression for the output when the input is n. Okay. Oh, that's okay. Do you want me to start the meeting again? Or you can reconnect if you want to. I think my internet is okay. There you go. Okay, so if you have a look at question 6, as long as your internet's been okay, we want to work out what the output would be when the input is n. So this is a little bit trickier. So we want to think we have an input of n this time. So it's not like a number, it's a letter. So that means you can't actually work it out. You just got to write down expressions. So if we added 2 to n, what expression would we have? Yeah, exactly. You'd have n plus 2. Now, what I'm going to do is put that in a bracket. Now, we put it in a bracket because the expression is all of n plus 2. It's not just n and it's not just 2. It's all of n plus 2. Then we want to times by 3. So I'm literally going to write n plus 2 times, or 3 times n plus 2. But because it's algebra, you don't actually have to write the times sign. You can just write 3 and then n plus 2. But you need the brackets because you need to do all of n plus 2 times 3. And that's what you'd have. So if we look at the second one, the output is 4x plus 5, which really means 4 times x plus 5. So the first thing we're doing is times in by 4. So I'm going to put times 4 in the first box. And then what should I put in the second box? Plus 5. Brilliant. Exactly right. That's exactly what I have. So that's number machines. So they ask questions like that quite a lot. The one then for 7. So have a think about 7a. Okay, have a go at 7a and just put it in the chat box, and we'll go over that one. Yeah, we're going to have n minus 5, and I'm going to put that in brackets. And then we're timesing by 4. So what's that going to be? Yeah, exactly. 4 bracket n minus 5. That's great. Well done, Josh. And then for the second one, we've got 3 times x plus 1. So we're going to have times by 3 because that gives us 3 times x, and then we're going to add 1. Okay, brilliant. So that's function machines. So if we look at rounding, and again, I have put all the answers to this on the team, so you can look at this after. So round the following to the nearest 10. So we need to remember what numbers are in the tens column. Okay, so if we have, say, the number 65, 5 is in the units, and 6 is in the tens. If I wanted to round it to the nearest 10, I would underline the 6, draw a dotted line, and then look at the unit. And that unit is 5, so it tells the 6 to round up. So we would end up with 7 in the tens, and then everything after that dotted line becomes 0. So to the nearest 10, that would be 70. So for A, if I underline the 4, draw a dotted line, and I'm underlining the 4 because it's in the tens, we're going to end up with 40, right? Because anything less than 5 tells us to round down. But anything 5 or more tells us to round up. So if I have 85, what would that be to the nearest 10? Yep, exactly. That's going to be 90. Brilliant. So we have 90. And then 286 is still to the nearest 10. So we underline the 8 because that is in the tens column. Dotted line. And this time you get 290. Because only the number that you underline actually changes. So we'd have 290. And then for D, the number in the tens column is 0. So I underline it. Dotted line. The 8 tells a 0 to round up. So I get 310. Okay. And then we're looking at rounding to the nearest 10 again. So with the number 5662, the number in the tens column is 6. So we underline it, dotted line. 2 tells the 6 to stay as it is. So we have 5660. And then to the nearest 100, we have to underline the number in the hundreds column, which is 6. So we underline that, dotted line. And we end up with 5,700. Okay? So it's all about, if you round to the nearest 100, you underline the number in the hundreds column. And then obviously here we're looking at rounding to the nearest 100 or 1,000. So the same thing, nearest 100, underline the number in the hundreds. So for the first one, we would get 6,400. And then have a go at B and C. Okay, so have a go at rounding B to the nearest 100, and then for C to the nearest 1,000. Okay, so have a go at that, and then we'll have a look at some. We got next. We got some symmetry questions. Okay, so have a go at B and C, and then we'll have a look at those symmetry questions. Yeah, that's great. 4,800. Well, then we get 32,000. Brilliant. So we got no issues there. That's great. So if we move on to the symmetry questions, how many lines of symmetry does this regular pentagon have? So remember, lines of symmetry are like how many ways you can fold something in half. So with this one, I can fold it in half once, twice, 3 times, 4 times, I haven't drawn it very well, and 5 times. Okay, so you can fold it in half on itself 5 times. So that means it has 5 lines of symmetry, right? 1, 2, 3, 4, and 5. So we have 5 lines of symmetry. And then the second bit, the order of rotational symmetry. To be honest, when it's a regular shape, like a regular hexagon, you can probably guess what it is. But what it strictly means, if I just copy this into, I'll just copy it into this app. What it strictly means is how many times you can turn it and it will fit into itself exactly. So we just copy into here. So what it means is how many times you can turn it and it will fit into itself. So we can probably see that it's going to be 6, but I'll just draw it anyway. I'll do an arrow like that. So basically we want to see how many times when we turn it through one full turn, it will fit into itself. Now, one full turn means as we turn it, the arrow is going to face upwards again. If we count it, we can go once to fit into it. No, it hasn't fit into itself there, sorry. Let me do it again. Right. Once, fit into itself. Twice, 3 times, 4 times, 5 times, 6 times. So that means the order of rotational symmetry is 6. So if we look at number 12, excuse me. For A, for the whole question, which two logos have more than one line of symmetry? So basically more than one line that you could fold the shape exactly onto itself in half. So just looking at those, which two of those have more than one line of symmetry? So just take your time, have a think about it. And to be honest, it's usually easier on paper when you can actually draw on it. So I agree with A for sure, because you've got one line of symmetry here, you've got another one here, and another one here. So that's three. I don't think B actually has any, because if I did this, problem is this part wouldn't fold onto there exactly, right? They wouldn't meet. If it was like this, it would, right? If it was like an 8, if it was a figure 8, if I can somehow draw that. If it was like this, it would. Just finish doing that. Yeah, if it was something like that, it would have a line of symmetry there. In fact, it would have two, but because it doesn't have those parts, it doesn't have a line of symmetry, I don't think. I think C actually does, though, right? Because if you go, well, if I look at C, if I go through here, oh, hang on, more than one, that's true, actually. Well, it's definitely got one like that. And I would say it's got another one like that. So that is two lines of symmetry. Now D is very close to it. The problem is I don't know if it has any. Definitely has rotational symmetry. But the thing is, if I try to fold it down this way, this part doesn't have anything to lie on here. So I don't think that is a line of symmetry. I think it's the same whenever you go from one corner to the other. I don't think it has any lines of symmetry. So I'm going to say for that A and C. And it's a lot easier when you have paper. Just try, because you will get tracing paper in the exam as well. So you could trace the shape and try and fold it. That might make it a bit easier. But for those ones, I think it's just A and C. Then for 13, we've got to fill in the missing numbers. So they quite like questions like this, okay? So for the first one, you've got 263 plus something is equal to 1011. So what do you think we'd have to do to work out what that missing number would be? Yeah, you'd have to take away the opposite of plus. So we'd have to do 1011, 263, and just carefully take them away, not to throw the marks away. So we borrow 1098. Can't do it. I borrow. 10 take away 6 is 4, 7. So I get 748 there. How would you work out the second one? So here I've got something, take away 248 equals 653. So what would I have to do in the second one? You'd have to add this time, yeah, but you'd have to do the opposite of minus. 653 plus 258, 248 even. 11, 9, 10, 9. So we'd have 901 there. Probably the trickiest one is this one. So what would I have to do to work out this missing number? I'm saying something times 43 is 1,161. So what would I have to do here? This time it's a divide. Well, I don't know my 43 times table, so I'm going to try and write down some of them. Because what I want to do is 1,161 divided by 43. And I can use a bus stop. So 43 into 1 goes none, remainder 1. 43 into 11 goes none, remainder 11. So I'm looking at doing 43 into 116. So what I would do is think of my 43 times tables. 43, add 43 is 86. Then add another 43 is going to be 129. Right, 86, 43, 80, 90, 100, 100, 120, 26, 129. So how many 43s are in 116? So basically, what number would go here? Well, 129 is too big, so it's only going to go once, twice. So that's going to be 2. And then I think about the remainder. The remainder is going to be the difference between 116 and 86. So if I just take those away, 116 take away 86, 0, 3, that's going to be 30. So the remainder is 30. So I need to see, right, 43 into 301. So I'm going to have to carry on my tables for a little bit. So 129 plus 43 is going to be 169, 172. Right, plus 43 again is going to be 132, 165, I think. Let me check that. 32 plus 43, 215, sorry. Yeah, 215. Plus 43, that is 258. Plus 43 again is 301. Right, okay, that's brilliant because that goes 1, 2, 3, 4, 5, 6, 7 times. So our answer there would be 27. So with the last one, I'm thinking something divided by 14 equals 48. So what would I have to do this time to work out the missing number? So have a think about what the opposite or the inverse of divide is. Times, brilliant. Okay, so we need to do 48 times 14. And there's loads of ways of doing that. So let me just get Word. I'll just do it on here. Just so we can make sure we're happy. Yeah, it did look a bit like a plus. That's true, actually. Yeah, it's a bit small. That often is the case. They do look similar. So what I'm going to do here, if I just don't really want to save this, I just want to delete that. Making me save that, okay? Let's leave that for a sec. Making me save this, right? Okay, so if we look at multiplying, if I want to do 48 times 14, right? 48 times 14. Now, there's loads of ways of doing it. So I think that probably the easiest way is to do the columns, right? So if I just get a better pen, there we go. So 48, get a better pen again, just make it a bit thicker. So I'm doing 48 times 14. So this is my preferred way, but I think this is the way that you do it, Josh, but there are other ways. People in the class do it differently. So I would do 4 times 8, which is 32. So I'm going to do 2 carry the 3. Then I do 4 times 4. So I'm starting with the units, times by the units, times the units by the tens. 4 fours are 16, plus the 3 is 19. Okay, so I put 1 in the hundreds, 9 in the 10, that's 19. Then underneath the 2, I now need to put a 0, because now I need to times by the 1, but the 1 is in the tens column. So I put a 0. Cross out the 4. 1 times 8 is 8. 1 times 4 is 4. So I have 480. Then I add them up. So 2 add 0 is 2. 9 add 8 is 17. So I have 7 carry the 1. 4 add 1 is 5. Plus the 1 is 6. That is 672. Are you happy doing it that way? Or do you want to have a look at the grid? Or there's another way as well, actually. So I think that's okay. Just another way of doing it as well. You can also do, if you've got 48 times 14, you can do it with the grid. So we have 40 and 8, 10 and 4. 40 times 10 is 400. 40 times 4 is 160. 8 times 10 is 80. 8 times 4 is 32. And we can add that up. Okay, that's fine. Yeah, that's brilliant. Okay, so I prefer the columns, but it's up to different people. So 672. And the next one, work out the first 4 terms of the sequence. So we're starting at 3, add in 4 every time. I think that's quite straightforward. Add 7, 11, and then they're going to be 15. That's quite easy. I don't want the nth term there. That's quite easy. First 4 terms of this sequence, just a case of being careful. So we're starting at 7. Take away 3, that's 4. Then we have 1. Then what would come next? If I need to do 1, take away 3, what would come next? So 1 take away 3, it's nearly 1 take away 3. Yeah, minus 2, brilliant. Okay, let's do a little check, that's brilliant. So number 16, getting a little bit trickier. So change 7 out of 50 to a percentage. So what I'm going to do, because I haven't got a calculator, I'm going to write it as a fraction. That's 7 over 50. Now, to make it a percentage, I need to make the bottom of the fraction into 100. So what have I times 50 by to get 100? Not quite 10. Have another think. Not quite 10. Yeah, you times it by 2. Brilliant. So, I think my internet's just cut out. Is it? No, that's okay. Yeah, we times it by 2. So what do you think I would have to times the top by? So times the bottom of the fraction by 2, so I times the top of the fraction by 2. So I get 14 over 100. Now, 14 out of 100 is just 14% because percent means out of 100. So that's what I'd have there. So before we do B, I'm just going to give you one to try. Can you have a go at doing 3 out of 50 as a percentage? What would that be? Yeah, that's going to be 6%. Brilliant. Okay, so brilliant. That's going to be 3/50ths, which is 600ths, which is 6%. So if I want to change 18 out of 20 to a percentage, I would start by writing 18 over 20. Then I would think, what do I have to times 20 by to get 100? And then whatever I times that by, I'd have to times 18 by. So what have I times 20 by to get 100? 50. Not 55, yeah? So what do I have to times the top by? So we'd have to times the top by 5 as well. So we need to do 18 times 5. So 18 times 5. So have a go at that. And then that's going to be what the percentage is. So just have a go at that one. Yeah, same as the bottom, we times by 5. So have a go at working that out. 18 times 5. 90%. Brilliant. That's 90. So 18 out of 20 is 90%. Brilliant. Okay. So we'll do a couple more and then we'll leave it for today then. I'll come back to it Thursday. So we'll do number 17. That's quite easy. What fraction of that is shaded? There's 3 pieces. 2 are shaded. That's just 2 out of 3. That's quite easy actually. But number 18. So what fraction of number 18 is shaded? We'll do the fraction and then we'll change that to a percentage. So firstly, for number 18, what fraction of that shape is shaded? Yeah, 3/5. Brilliant. So we say 3/5 is shaded. So what would that be over 50? So 3/5 is going to be what out of 50? So think about what I've had to times 5 by to get 50. Yeah, 30 out of 50. Brilliant. Now, what is that going to be out of 100? What is that going to be out of 100 then? 60. Brilliant. So we can say that 60% of that shape is shaded. That came up in 2020, so it's quite a common question. Brilliant. So number 19, they want us to find the size of angle X, not with a protractor. They want us to work it out. This comes up every year. So we need to remember what the angles on a straight line will add up to, or what the angles on a straight line will make. So what do angles on a straight line add up to? 180. So to get X, we just have to do 180, take away 124. So 7, 6, 7, 6, 5. We just have 56 degrees. Okay, so that's quite a nice one, but again, it's all about remembering what angles on a straight line add up to. And then number 20 is sharing in a ratio. So we want to share £40 in the ratio 1 to 4 between Tim and Sam. So it's sometimes nice to do this as a picture. Okay, so we think got there's 1 part for Tim and there's 4 parts for Sam. So if I want to work out what 1 part is worth, I want to work out what 1 part is worth. I notice that I've got 5 parts, and that is worth £40. So how could I work out what 1 part is worth? Because there's 5 parts between them, and that's worth £40. How much is 1 part going to be worth? It's going to be 8. Brilliant, because you just have to do 40 divided by 5, which is 8. That's 1 part. So that's how much Tim gets, right? He only gets £8. How am I going to work out how much Sam will get? So all you'd have to do here is say, well, if 1 part is £8, Sam gets 4 parts. He is going to have 8 times 4, which is £32. Okay. Right, so if I just look at where we are here, so if I zoom out a little bit. So after this, we've got the algebra questions, a couple of algebra questions. Then there's a little bit of perimeter and area, a little bit of time, and then you've got some coordinates questions, some indices. So we'll carry on with these on Thursday. That's what I'll make a call then. But thing is, if you want to go through, if you want to do these yourself as well, you can do them on MathsWatch. So just let me know, Josh, if you need your login details or anything. And if you are doing them in the meantime, please message me if you've got any questions. Okay. So all of these are based on the 2020 paper. So they're all quite similar to what you can expect in your exam. And then after these ones, you've got and in fact, let me just quickly get what I put on Teams for you. So here we go. So I've put this on the team for you here, okay? So if you go on to the team, you should be able to find this document here. And what it is, in fact, let me get the full thing. I have actually made it into a full thing here. No, hang on, where's the booklet? I've made it into a full thing actually. Let me get it up now. Here, one sec. Here we go. Here's the revision. No, that's not the one. Hang on. Put it into the other team, which is. Here we go. Yeah, here we go. The revision with answers. So if you click on that on Teams, it should take you to this document here. It's quite long, but basically what it is, you've got all the MathsWatch questions. So you can try those on MathsWatch itself and it'll mark it for you. But then the answers are all underneath. So if you're really stuck on a question, the answers are way down here. If you're really stuck on the questions, just have a look at the answers to help you. And you've also got all the clips here. Okay, so for each of the questions, there's a clip, and sometimes I put some of my own videos on there as well. Okay, so if you click on any of these clips, so for example, we're on sharing in a ratio. That's what we're on now. If you click on the link, then you've got to put your login details in, so clip, and you'll be able to watch it. Okay, and that would help you with the question. So have a go at some more of these non-calculated questions now, and then I'll do another call on Thursday. Okay, so we'll leave it there for now, but have a nice afternoon. And please do message me if you're stuck with anything.